Hi Engineering Janta, I am Vaibhav Shukla and today I welcome you all to the part 2 of Infix to Postfix implementation using stacks. This is another video in the free DSA series that we are building for you so that you thrive high in your career. So for those who have watched my previous video carefully, for them this video is going to be a cakewalk. For those who haven't, go ahead, watch the previous video first. Fine. Now I'll go ahead. And I've explained you all these steps, how they work in the previous video, and now we'll learn the code implementation. So here we'll be executing the push pop functions using the stack library of C++. Fine. So the first thing you do is you check if the character that you're scanning is an operand. You need to check that. I told you while scanning you need to check that. So I declare a function that checks this. Fine. Check if operand. It takes character ch. It returns the character if it is from A to Z or it is from this capital A to capital Z. Anything in this range. Fine. Now, anything which is not in this range, which is basically operators, they'll be handled differently. Fine. Now I come to the precedence function, where the precedence of your character that you scan, if you scan any operator, it would be decided. So higher the number, higher the precedence. Fine. Now you can ignore this bracket, this shouldn't be here. So for this switch, what I'm going to do is I've used a switch here. It takes a character, this precedence function takes a character. If it is plus or minus, then the precedence is set 1. It will return 1 because this takes integer as its return type. So it would set return 1. Fine. So it would set precedence as 1. If it is multiply or it is divide, then in that case it would return 2. If it is exponential, then it would return 3. Fine. If there is no symbol, any symbol apart from these particular characters would be discarded and -1 would be returned as default value. Fine. Now we start converting infix to postfix. The first thing was we declare two variables, two normal integer variables, and then we declare a stack of characters which is s. Fine. You declare a loop where I is starting with 0, j is starting with -1, and till expression I exists, till it is true. Fine. You keep on incrementing the I. Fine. Also what you can do is you can put a condition of size of stack, then also this will work. Fine. With that you can also work. Now in this case, if I go further, I check if operand expression I, which basically means in this if I am checking the condition whether the character I scanned, say for example this was the expression I had, fine, a plus b star c, fine. So if this was the way that I had to implement, I'll check with the first character that I scanned. Is it an operand? No, it is not. So this if block will not execute. Fine. I go ahead. And let's imagine that there is some expression which we are going to output later on. So this I'm writing just for the reference. Don't consider it anything else. Fine. This is just for a separate reference that I am writing. This would be our output, our final output. Fine. Now it is saying else if expression I is equal to opening bracket. If it is equal to opening bracket, is this condition true? Yes, it is true. So push the expression I in the stack. Basically what I am saying is what you scanned was the opening bracket. So push it here. Fine, in the stack. Now once you do it, once you have done it, you further try and check what's happening. Now this has been executed, this else if portion has been executed, further things won't be true, hence it won't execute. Fine. Now I go further and right now it's not an operator, so there's no point checking it. So this is not needed. Fine. Else if an operator is needed. So just a minute, I guess that's a comment that I put. Yes, that's it. So what you will do is Rest of the things we'll understand as we scan the further elements. Fine. So let's scan the further element. Further is A. Again, you start with this for loop, because if you carefully see, this for loop's execution has ended because none of the other things can be done right now here. One thing could be done is done. Fine. Further things of checking an operator. Fine. Here, what I can do is, while s dot empty, which basically means s is not empty, fine, stack is not empty, and the precedence of expression I is less than equal to precedence on the top of the stack, fine, then these things would have been implemented. For those particular steps where it is being implemented is when we scan operator. Fine, we'll come to it, don't worry, we'll come to it. So what happens now is, again I check if there is an operand, because this is incrementing, I is constantly incrementing. I go ahead, I check if it is an operand, it is an operand, fine. So what will happen in this expression, A would be stored. If you carefully see, this is what I'm doing, expression plus plus j, j was -1, you increment j to 0, and on the 0th index of this expression you store this, fine, because expression was a character pointer where it could dynamically allocate the memory, fine. So here I put A. Now I check for the further characters, fine, I go back again, I check that it is an operator plus. Now all this is useless because it is not an operand, fine. Had it been an operand, it would have been stored. It is not an operand, it is not a parenthesis, it is not even this parenthesis, fine. So if it is not this parenthesis, if it is not this particular opening parenthesis, what should I do? I should check whether it is an operator or not, fine. So if it is an operator, then in that case what I'll do is, this else block will execute. What is this else block? While s is not empty, and basically I'm saying that my stack is not empty. If you correctly remember, my stack has an opening bracket right now. So this is true, fine, because stack is not empty, and precedence of expression is lesser than equal to precedence of any symbol that is on the top of the stack. Now in this case it is not the case, because I have scanned plus. Plus has greater precedence than this, fine. So all I can do is, I can simply push it inside the stack. Fine. So what I'll do is, I'll simply push it inside the stack, fine. Now after doing this, once I have done this, what I can do is, I go back, I check for this particular value. This is again an operand, this will execute, rest of the things would be ignored. Again this is done. Now when I go further, I get this closing bracket. Now when I get the closing bracket, this portion of code gets executed. In this case, while s is not empty, which is true, s is not empty, this is true, and the top of it, fine, is not, so if you correctly remember, now this is how our stack looks like, fine. So the top of the stack is not the opening bracket, this is not the case. Now if this is not the case, what you can do is, you put this, you increment the expression plus plus j, basically you pre-increment the value of j. J was right now here, you pre-increment it further, fine, j goes here, and after j goes here, what you do is, you put what was on the top of the stack, which is plus, fine. So I put it here, and then I pop. So when I pop, this gets removed, and when this gets removed, what you do is, you go further. If s is not empty, yes, it's not empty, and stack of top is not equal to this. Now this is not the case, this is not the case. So you pop, as simple as that. This is the same block going on, you pop and the pop happens and you clear it off, fine. Now what I'll do is, I'll go further, I'll scan for the star, the operator is available, operator should be pushed inside, fine, because we can push it simply, there is no precedence problem that we are having right now. So if there is no precedence problem, what we can do is, this is now empty, the stack is empty now, what we can do is, we simply push it and then we go further, we find an operand. What we'll do, we'll go and we'll check for this, we'll find an operand, we'll print it, it gets printed here, and then what we do is, now there's a careful catch, because now there is nothing to be scanned. When there is nothing to be scanned, this loop starts functioning while S is not empty. Basically when stack is not empty, what you do is, you keep on updating the expression with whatever you have here on top, and then you keep on popping. This is all the steps in the chronological order that we did in the last video. If somebody has understood the last video well, then this code piece is cakewalk. If you've not understood it well, you will never understand this code, as simple as that. तो पिछला वीडियो ध्यान से जाके समझ लो, सिंपल सी बात है, फाइन. सेम चीज हो रही है यहाँ पे, सेम एग्जांपल भी ऑलमोस्ट सेम लिया मैंने, फाइन. सो इन दैट केस, व्हेन द स्टैक इज not empty right now, what I'll do is, I'll update the expression. Right now if I tell you that J was pointing to this particular location, now I pre-increment J first, which basically means I increment J further, J starts pointing here, and at this location, this is the stack top right now. For this top, I put this expression, I update this expression. So this is the multiplication operator. Wait a minute, I'll draw it better. So in this case, this multiplication operator would be updated here, and then this s dot pop will execute, which basically means I will pop this out. Now once this gets executed, you update it with the final value, which is this, which often represents that the string has ended, because you need to end string somewhere, fine. So I'll end the string with this character, I'll pre-increment the J again the J gets incremented first, fine. So J will be incremented here, and here this character would be introduced to end the string, fine. So basically this is the ending character, just imagine it like that. That's why I have put it in these inverted commas. Now this much is your postfix expression, and this would be printed using this printf command. Now for all those who are thinking, ये printf कैसे काम कर रहा है, how this printf is working in a C++ code, printf works in C++ code, okay. This is very normal practice. You want to write cout, you want to write printf, it's your wish. So using this it can work, fine, and the string would be printed, very simple, fine. So this is by far the code expression. So what I have done is, I have taken the a different kind of example is available here. So you can do the same example using this, that's your homework, fine. What you need to do is, I'll post this once 3 or 4 comments come about the expression that you converted using this expression, fine. This is the homework expression that I have for you. And I have taken one example, I have shown you how things can be done. Now you dry run using this particular expression. If you face any doubt, go ahead in the comments, tell me what doubt it is, I'll solve that out for you, fine. Also, how this particular function is executing, that can be done once you step by step execute it on your copy, fine. So what you can do is, also on prepinsta.com, this code is available for free. You can search infix to postfix conversion C++ prepinsta, fine, and you will find this code, this complete same code, fine. There similar example is available, but before going there, try figuring out what is the postfix expression for this, Fine. Try figuring it out yourself. If you don't, go ahead, see the solution on prepinsta.com. Fine. But first of all, it's good practice to try it yourself. Why I am not going into the detail of this expression is because if I don't give you the regular practice of coding, you will not understand how it is done. It is necessary to go yourself and try and practice things. Fine. So go ahead, and what I can tell you is that tell me in the comment section that what. So go ahead, comment below this video, because top 3 comments get Prep Insta Prime subscription for free, so they stand a chance to win that. Also, follow us on these social media links so that you never miss any hiring update. Fine. Just keep doing good for people. Good will come back to you. Fine. And if you find any doubts, comment section is always open. Go ahead, tell me, I'll resolve them for you. Fine.